Hi everyone, I hope you're well. So, we are going to start with decimals, and if you have your textbook with you, it's going to be on page 59 that we are going to start. And the first topic that we're going to do is called 5.1 integer powers of 10. And this is on page 59. There we go. And you will see I am just going to work with you through the examples. They say that we already know that 10 times 10 times 10 can be represented by 10 to the power 3, and that also equals to 1000. 10 times 10 equals 10 to the power 2, which equals 100. 10, just like that, can be represented by 10 to the power 1, and that equals to 10. Okay, so if you turn the page, just turn it here. They say, look at the list. Two things happen each time with the power, and that is that it's reduced by 1. You can see that every time we make 1 less 10 being multiplied with the original 10, that this exponent decreases by 1 every single time. So from there to there is 110 less, this is 110 less. And when I say that, I mean it's literally the amount of tens that we multiply. So if we say 10 to the power 3, 10 to the power 2, 10 to the power 1. You can see that there's only 1 there. So that's all they say. We just have to make sure that we see that visually. So we just need to focus on that part there. And then they say the pattern continues. This time we have 1. Now in terms of 10, that is going to be 10 to the power 0, which equals to 1. Then we have 0. Okay, wait, let's before we do the decimals. Now we have 1 over 10. And then we say if we continue this pattern, so what would be 0 minus 1? It would be minus 1, which equals to 1 over 10 again, so I'm not going to write that, but in terms of decimals, it's going to be 0.1. Next one would be 0.01, 10 to the power negative 2, and this is going to be 1 over 100. Or, like they say in the textbook, 10 times 10. The next one is going to be 10 times 10 times 10. So that's going to be 10 to the power negative 3, which is 0.001. So they say writing numbers as 10 to the power 2 and 10 to the power negative 3 is sometimes called writing them in index form. So index form looks like this. 10 to the power 3 or 10 to the power negative 2. These would be the index forms. So we can actually say this entire column over here is called index form. And that is all they want us to do there. So if we go through the worked example, worked example 1. So the first one we have to do is A, and we have 10 to the power 6, and we also have B, which is 10 to the power negative 5. Now for A, they say write the value for each of these. So to write the value of 10 to the power 6, we know it's going to be 10 times 10 times 10 times 10. So there are 4, 5, 6. And 10 times itself 6 times is just going to be 1. And then 1, 2, 3. 1, 2, 3. So altogether that would be 6 zeros. And that is also the number for a million. And 10 to the power negative 5 is going to be 1 over. Whenever you see a negative exponent, it's always going to be at the bottom if you want to make it positive. So it's actually 10 to the power 5 if we want to make that exponent positive. Now instead of writing 10 to the power 5 at the bottom, we also know that 10 to the power 5 means 5 tens multiplied with each other, which equals 1, okay, 1, 2, 3, 4, 5. So that's 100,000. But since it's 1 divided by that, just for in case if you forgot how this works, so the number 1 we can write like that. That still equals to 1, right? This still equals to 1. So I usually like to write a few zeros, and then I ask myself, by how many zeros are we going to shift the decimal place? So there are 5 of them. So I'm going to take this decimal place and say 1, 2, 3, 4, 5. So the decimal place is going to be over there, which means our answer is going to be 0.00001. And that is all we had to do there. So these are the actual values. We don't want them in fractions, we want them in decimals so that we know exactly what they equal to. Then worked example 2. Worked example 2. Write each of these in index form. So this time they give us A as 10,000. B they give us as 0.0001. Okay, for A it's 10,000, so it's going to be 10 to the power. So since there's already a 10 there, just count how many zeros you have there. So it's 3 and then the 10. I take that back, my bad. You just count how many zeros you have there, and then you know by what you should multiply 10 with. So 10 times 4. And then B, so we have 0.0001, and if you write 0.0001 and you shift this, so there's a 0 there, so that shifts there, and then there, you just take that last little. I usually like adding in the zeros just to help me. 1, 2, 3, 4, 5. Okay, so that seems to be 5 to make it a 10, but we actually just want, oh, 1, 2, 3, 4. 10 to the power negative 4. I just want to check something. The textbook says that it's 10 to the power negative 4. I just quickly want to check if that is true. So if we have 1, oh yeah, so it's 1 divided by 10 times 10 times 10 times 10, because we have 4 zeros. 1, 2, 3, 4. Then this makes sense. I was thinking if we make this little arrow go and make this a 10, then it's only going to be to the power 3, 10 to the power 3. But if we say 10 times 10 to the power negative 3, then this would be true. But since we already have that 10 there, sorry, I'm really struggling to focus. Okay, next thing that we're going to do is multiplying. So we're just going to a new page. Multiplying and dividing by integer powers of 10. Okay, so, whoa, that's not what I wanted to do. There we go. So first write the power of 10 as a number if the power is greater than 0, or as a fraction if the power is less than 0. Then multiply or divide. You can do a quick check to see if the answer is likely to be correct. When you multiply a number between 0 and 1, your answer will be smaller than the one you start with. And when you multiply the number between 0 and 1, your answer will be larger than the one you start with. Okay, so we are going to start with the worked example. Just for in case, I was reading on page 60 there under the heading multiplying and dividing by integer powers of 10. And I'm starting with worked example 3, and they say work out 245 times 10 to the power 3. Okay, so that's going to be 3 zeros that we need to keep in mind. So we have 2, 4, 5. So this is the original number. You don't have to do this. This is just one of the ways that I like to do this one. So 3 zeros would be 1, 2, 3. So the new decimal point will be there. So that means our final answer is going to be 245,000, and that's that. So for B, 0.25 times 10 to the power negative 1. Okay, so again, I like to add in all of these zeros. Oh, my pen just went flat. Just give me 5 seconds.
That's better. Thank you.
Okay, so let's see. So this should work. There we go. Yeah, so I like to write these zeros like this, and now I'm going to multiply with the power negative 1. Okay, so all that means is instead of going to the right, making the number bigger, I'm going to make the number smaller again. So this is the new decimal place, so that means our number is equal to 0.025. And just put that there so that you know which ones are the final ones. This is how I like to do it, but let's also show how they would like you to do it if you like the textbook's method, which is also really good. So the textbook uses this 0.25, and then instead of multiplying with this 10 to the power negative 1, they write it as a positive exponent, and then you just read it as 0.25 divided by 10, which is then exactly what we were doing. So when you divide by any number, then you usually go to the left. So that's for division. And if you multiply, you're going to go to the right. Okay, so you will still get the same answer. It's still going to be 0.0025. Okay, and then let's do C. I would suggest, if you can, before you see how I do these, pause the video and try to figure it out on your own. And then you can just check when you unpause the video to see how you did. So we have 2.45 divided by 10 to the power negative 3. I usually don't like division, so I would like to turn that into a multiplication. So I'm going to say 2.45. And in essence, we're actually saying this. And whenever, so there's this rule in fractions, whenever you see a division, first you tip and then you times. So when you see division and a fraction, you tip and times. So what that means is we're going to tip this, so the top becomes the bottom, and the division becomes a times. So 2.45, so we're going to times, and now it's going to be 10 to the power 3 divided by 1. So in essence, we're actually saying 2.45 times 10 to the power 3. So that means 1, 2, 3. So imagine there's a 0 there. This is why I usually like to add in zeros, just so that I don't mess up anything. But what this means, it's going to be 2,450. So there's a bunch of zeros there, a bunch of zeros there. But the answer we're looking for is this one over here. So 2,450. If you got that one right, well done, because you had to remember a bit of the fractions as well. And then D, we have 230 divided by 10 to the power 2. So I don't have a fraction this time, and if you want to, you can tip in times, but it's not really going to make that big of a difference, because you're still going to have to say 230 divided by 10 to the power 2, which means there's going to be 2 decimal places that we need to change. And since it's division, we're going to go to the left, because you go to the left when dividing and you go to the right when you multiply. So we're just going to go 1, 2. So this is the new decimal place, so we can just put that like that, and 2.3. Okay. So I would like you to try. So everything I just did is on pages 59 to 61. I would like you to try exercise 5.1, and everything on the left hand side, from number 1 to number 6. I think those are the only numbers we had to do there. Number 7, you can try number 7. So if you'd like to try, you can also do number 7. And that would be all for integer powers of 10. I hope this helped. If it didn't, please ask me. I would like to explain anything I didn't get to cover. I am sorry for the monotonous tone. I'm a bit tired, and I'm also trying to keep a class still while making the video. But yeah, enjoy the rest of your day, and please let me know, maybe in the comments, or if you do have my cell phone number, just to help you with this. But yeah, hope it helped. Okay, so exercise 5.1, number 1. They say write each of these in index form. So we have a 10 with about 6 zeros, and in index form this would be 1 to the 10 to the power 7, because we have 1, 2, 3, 4, 5, 6, 7. So just for in case, this means 10 times 10 times 10 times 10 times 10. So 1, 2, 3, 4, 5, 6, 7. And if you add all of them, then you have 1, 2, 3, 4, 5, 6. Okay, so 10 to the power 7. And then for 2a, write down the value of each of the following. 10 to the power 3 just equals to 1,000. So, which also means 10 to the power 10 times 10 times 10. Then for number 3a, we have 2.3 times 10 to the power 2. So I usually like writing it out like this. So times 10 to the power 2 means 1, 2. So that's the new decimal place. So it's going to be 230. And then E is the next one. 0.45 times 10 to the power 2. So 0.45. Now since we're multiplying with a number bigger than 1, so 10 to the power 2, which is 100, means that we're going to go to the right 2 times. So that's the new decimal place. So this is going to be 45. And that was number 3. Number 4, they say work these out. 289 divided, so 289 divided by 10 to the power 2. So 289, since we're dividing with 10 to the power 2, we need to go to the left. So 1, 2. So that's the new decimal place. So okay, my pen just struggled again. But that would be 2.89. That was for A. For E, 0.25 divided by 10 to the power negative 3. Okay, so whenever you see a negative and a negative exponent and a division, 0.25 divided by, we first make that negative exponent positive by putting it at the bottom. And then when you see a fraction and a division sign, you tip and times. So this basically means we have 0.25, and we're multiplying with 10 to the power 3, so we're going to go 1, 2, 1, 2, 3. So that's the new decimal place. So that means we are going to have 250. Okay, and then that was number 4. So number 5. So we have 40.8 times some unknown number equals 408. Copy each of the following. Replace the question mark with the integer power of 10 that makes the calculation correct. Okay, so we need to say, instead of using that equal sign, since there's already an equal sign at the top, we can just write this here. We need to say 10 to the power something equals 408. And it seems that this decimal place just moved a single space to the right. So one decimal place means that it's going to be 10 to the power 1. My pen just died again, so I'm just going to quickly plug it in. And here we go. There we go. So 10 to the power 1, and now we're done with number 5. For number 6, copy each of the following. Replace the question mark with a value that makes the calculation correct. Each of the numbers needed has the digits 2 and 4 in that order. Has the digits 2 and 4 in that order. Okay, so 6a, we have some unknown number times 10 to the power 3 equals 24. So if you think about it, I need to stop doing that. We have 24, and it was something, probably something smaller, because we multiplied it. So it was probably like 0.024, something like that, and we multiplied it with 3. Okay, I think that might actually be the answer. But I was just like playing around with the numbers now. But we had to multiply it with 10 to the power 3, or 10 times 10 times 10. And that gave us the new decimal place, which gave us 24. So in this case, this is what happened. But I want to show you how we can do the opposite of taking a small number and multiplying it with 3. We can say this 24 divided by 10 to the power 3. Then you kind of say this unknown number equals 24 divided by 10 to the power 3. So 24 divided by 10 to the power 3, that is actually the next step. So I am just going to write this unknown number is equal to 24 divided by 10 to the power 3. Just for in case, 2 times 3 equals 6. Let's say we did not know that that would have been 2. We say then, let's say we don't know that's a 2. This unknown number equals to 6 divided by 3, and 6 divided by 3 is 2. And you can see there that we actually did start with a 2. So that's in essence what we are doing. And then 24 divided by 10 to the power negative 3, so it's going to be 1, 2, 3. So the new decimal place is there. Well, actually the old one. But this is the value of 0.024. So that's the value that unknown number was originally. Okay, so that was number 6. And let's see if we can do number 7 as well, if you tried it. So they say Khalil, so let's just write here. Okay, Khalil is given this calculation by his teacher. 245 something unknown number equals 2.45. He has to replace the square with multiply or divide. He has to replace the question mark with a number. He says there is more than one way to do this. Find as many ways as possible to replace the square and the question mark. Okay, so we can say 245. So originally it was that number, and then the new number shifted this to the left. So the new number was 2.45. And this shift over here, we can either say we divided by 10 to the power, how many times did we skip? 1, 2. So it's going to be divide by 10 to the power 2. So that's one of the options we can do. So, and somehow we should be able to multiply as well. So if we multiply, we can multiply with 10 to the power negative 2. The reason why I say that, if you say times 10 to the power negative 2, that equals to times 1 over 10 to the power 2. Now anything you multiply with 1 and then divide by 10 to the power 2, that equals to just dividing with 10 to the power 2. So there are at least two ways there. If you want to, you can test all sorts of different ways, but for now I'm just going to stop with this. And that is all you had to do. If you found at least two different ways, then that would be good. So we can just say possible would be multiply and divide. And then the unknown numbers could be 10 to the power 2 and 10 to the power negative 2. That's it. That's all you have to do. Hope this helped, and if you have any questions, please ask me.